This video is part of the course introduction, and what we hope to accomplish with this recording is to show the trainer board that we're going to use on and off through this course along with live equipment for demonstration purposes. What you see in front of you is actually the control system for a standard air conditioning system. Split system, could be a package unit, could be whatever. Okay, we have our power supply, which comes in off an outlet. This is a 120 volt board. Most of your systems will be 240 or up. Okay, we have our transformer down here at the bottom corner. This is the component that changes the 120 to the 24 volts that we like for our thermostat. We have our thermostat. In this case, I'm going to use a digital thermostat. We have our contactor, normally found in the outdoor unit. This controls the compressor and the condenser fan motor. We have our indoor blower relay. This is the component that turns on and off our blower to move the air around. We have some additional components on the board. There's a time delay here. It's right now not connected. And we have an additional sequencer here. Again, not connected at this point. We're using, for our system right now on this board, we are using light bulbs in order to simulate the motors. Again, just easier for demonstration purposes. I have an indoor fan motor over on the left side here. Then we have our compressor. Then we have our outdoor fan motor. Again, the sequence of operations will be the same. So when we walk into a house in order to troubleshoot air conditioning or any building whatsoever, we really want to start at the thermostat. The first thing that I do is I push the thermostat to fan on. Okay, the reason why I want to do this, I need to make sure the thermostat is working. I need to make sure we're getting proper power, and I need to make sure our air handler's working. You'll notice that about a couple of seconds after I flicked the thermostat to fan on, the indoor fan motor came on, or what we're simulating for the indoor fan motor. Now what that tells me is that the thermostat is getting 24 volts from the transformer. It also tells me my air handler is doing exactly what it should be doing mechanically. Okay, so if I have a blower motor come on and my air handler is working properly mechanically, okay, it's a step in the right direction. So I'm going to turn my fan back to off, or sorry, auto. That's going to go off, turn off, because we have no call for cooling. And again, with a digital thermostat, there's delays. Okay, now, I'm going to turn down my temperature to under room temperature. Okay, my room temperature 77 degrees, a little bit warm in here. And now I'm going to turn my temperature down, and you will see that all three components lit up. Okay, my indoor fan is running, it's blowing air around, or it's supposed to be running. Okay, my compressor is running, and my outdoor fan motor is running. So, real quick, let's review the sequence of operation. My thermostat is calling for cooling. In other words, my room temperature is 77. My thermostat set point is 71. Thermostat is calling for cooling. My indoor fan motor comes on. My compressor comes on. My outdoor fan motor comes on. We'll show you the voltage readings on this in a little bit. If I turn my thermostat back up above room temperature, we will notice what happens next. Again, there's a little bit of a delay. And all of a sudden we see that all components shut back off. So sequence of operation: on a call for cooling, we turn on the indoor fan motor, we turn on the compressor, we turn on the outdoor fan motor. Okay, when we look at the components here, on a call for cooling, the contactor is energized, and the indoor blower motor relay is energized. Thermostat terminals are always underneath the cover here. You pull this off. Okay, you see the little terminal connections here. Always check the batteries. And then behind the panel here, you can actually access the wiring. We're going to talk more about that when we start talking about volt readings and taking some meter readings. Okay, and I'm going to just click this back on. Now it doesn't matter really other than look of the thing. Does the thermostat for a digital thermostat have to be level? No, there's no mercury in it. Okay, if it's a standard non-digital thermostat and has mercury in it, yes, it has to be leveled or it will not work properly. So hopefully that showed the basics of the trainer board we're going to use for demonstrations. And these are relatively easy to build on your own if you'd like to do so.